Jnanam Paramam Dhyayam. Knowledge is supreme.
This tutorial is a special tutorial, because I say special because this tutorial is made for you for more number of practice problems. So, it contains more practice problems which you can do on your own. These practice problems are simple ones which I will not discuss, but you can try it. It will be 1 or 2 line problems which you can attempt based on Pauli spin matrices and orbital angular momentum operator. Those are very simple exercise which has been included in this tutorial, so that you can try more number of problems. So, I will discuss now the first problem, which is you have already seen this Schrodinger equation solution in terms of r theta and phi using separation of variable. So, you are given a Schrodinger equation for theta and phi equation, and you are asked to make some substitution wherein omega or w is cos theta, and you have to substitute for capital theta as p and try to solve this equation. And in this equation you have to solve this by substituting or taking p as a omega square minus b, a general solution for p or theta in terms of omega. Omega is cos theta. So, we have to find the solution of this equation, and in doing so you have to find the possible values of the fraction a by b, which are some constant L and ml. So, we have to write the form of capital theta and phi in terms of these solutions what we get for a by b, L and ml. So, let us get started. You are given the Schrodinger equation, first problem, Schrodinger equation for capital theta and phi are given by capital theta, it is given to you sin theta upon capital theta, dou by dou theta, sin theta, dou by dou theta multiplied by L into L plus 1 sin square theta is equal to ml square. Okay. And this you can actually rewrite by taking capital theta on the numerator, okay, which later we will do. So, this is for equation for capital theta, then we write the equation for capital phi. Equation for capital theta, equation for capital phi is nothing but 1 by phi. So, this Schrodinger equation is in spherical polar coordinate, you get this form d square phi by d phi square is equal to minus ml square. So, do not get confused here, this is capital phi and this is a small phi. Okay. Now, when you rewrite this by substituting, so substitutions made are substituting theta is equal to cos theta is equal to omega. Okay. So, what will be sin square theta? It will be 1 minus omega square or w square, you can call it as w or omega. So, this will be sin square theta is 1 minus omega square, p is capital theta, and I want to rewrite dou by dou theta in terms of dou by dou omega. So, that will be rewritten as dou by dou theta will be nothing but minus sin theta dou by dou omega. Okay. Now, this is a function of theta only. I can write it as capital complete differentiation instead of partial one. So, this will be d by d theta is d by minus sin theta. This I have got from here, because this is nothing but d theta upon d omega upon d theta, which is nothing but minus sin theta. This would imply that d square by d theta square will be equal to sin square theta d square by d omega square, correct. Now, these substitution we will make in first and second equation. Second equation is very simple, we are not supposed to touch anything here, it can be solved easily, but we need to know what is the value of ml. So, value of ml you will get by solving the first equation. So, let us make the substitution, and in doing so we substitute for capital theta and take it in the numerator, and in this step we are also trying to rewrite this in terms of omega. Okay. So, let us do that. So, this will become sin square theta, okay, dou by dou omega sin square theta d by d omega, here also d by d omega, plus L into L plus 1 sin square theta, because I am multiplying throughout by capital theta, I will have additional term here. So, I will write throughout common as capital theta, correct, here, which is nothing but P is equal to 0. Okay. This is the equation we have now. Now, what we do is we divide throughout by sin square theta, okay, and make the substitution for omega, which we have not done yet, because we have to find out the terms in terms of differentiation. So, d by d omega sin square theta is 1 minus omega square d by d omega, this is entire term like this, plus L into L plus 1, I am dividing by sin square theta. So, I will have ml square upon sin square theta, which is nothing but 1 minus omega square, and here there is a p. Now, it is very simple, here you will do the differentiation. So, here you will have, let us do it, and at the same time we make a substitution for p. P is a omega square minus b. So, from here you can write what is p prime. P prime is 2a omega, that is dp upon d omega is 2a omega, and 2 times when you differentiate you get 2 times a, right. Now, I will substitute these values in this equation. So, again when I do the differentiation, I will have 1 minus omega square term d square omega by d omega square, d square p omega, d square p upon d omega square, which is nothing but 2a. So, let me write here 1 minus omega square times 2a, correct, minus, again come back here, I will have, when I differentiate this with respect to omega, I get minus 2 omega and times 2a omega. So, that becomes 4a omega, correct, plus L into L plus 1 minus ml square upon 1 minus omega square, and here I have to substitute for p. P is a omega square minus b. So, a omega square minus b, I divide in this equation itself by b throughout. So, here I have a by b omega minus 1. Again I feel little inconsistent, so I will just not inconsistent, but it will be easier if the omega term is in the numerator. So, let us bring it back. In the previous step I had divided, but you do not need to divide here. So, let us bring it back here. I have 1 minus omega square minus 4 a by b omega 1 minus omega square. Then here you have L into L plus 1 minus omega square minus ml square. This times here you have a by b omega minus 1. Okay. This entire thing equal to 0. What we will do is we will compare the coefficients of omega and write the coefficients of omega individually. So, each coefficient will individually go to 0. So, the omega raised to 0, that is when the coefficient of omega that is 1, omega raised to 0 is 1. So, coefficient of omega 0 will be the first term. From here I will have one term, that is 2 a by b, okay, 2 a by b minus, here I do not have any coefficient of omega, here I have one coefficient of omega, that is omega raised to 0, that is L into L plus 1. So, I have here L into L plus 1, okay, minus ml, correct, minus ml. So, this entire thing multiplied by minus 1 for coefficient of omega raised to 0. So, this when I multiply throughout by minus 1, what do I obtain is this minus and minus becomes plus, and there is a minus L into L plus 1 to ml square. This goes to 0. So, this is my equation number 1. Okay. Then coefficient of omega square, there is a power of omega square. Here I will get 2 times 2 omega square, that is minus 4 a by b, and from here also I get minus 4, here it is omega square, oh sorry, it is omega square here, right, here also it is omega square. So, here I have omega square term which will be minus 4 a by b. So, this becomes 8, correct, 8 omega square a by b. So, coefficient of omega square I am writing. So, it will be minus 8 a by b. Next will be term coming from here. So, we have already multiplied by minus 1 for the first term. So, from here I will have minus L into L plus 1. So, minus L, so this becomes plus L into L plus 1, correct, and then I have here also I have a omega square, sorry. So, here I have now again the first term of this, when I take the cross term I have L into L plus 1. So, plus L into L plus 1 a by b, and here I will have one more term which is minus a by b ml square equal to 0. Okay. So, this is our equation number 2. Now, let us find out equation for omega square term or omega raised to 4 term. So, omega raised to 4 term, let us find out. So, this will be one contribution, this is 2 a by b omega raised to 4. Here I have minus and here I will have a omega minus and minus plus. So, 4 a by b. So, it becomes 6 a by b, okay, omega square, omega raised to 4, one contribution I got from here. Another I will get from here which is minus L into L plus 1 a by b is equal to 0. So, this is the third equation, but what does this imply? This would imply that L into L plus 1 is 6. Okay. So, here I have solution for L from the third equation. Now I will make the substitution in these equations. I will use first and second to get the value of ml and the ratio A by B. So here we have one equation. Let us do it. So this becomes, I will use this substitution here. So this becomes 6 plus 6 A by B. So this will be minus 8 A by B plus, this is 6 and this is 6 A by B. So 6 plus 6 A by B, correct, and then I have minus A by B ml square equals to 0. So minus 2 A by B. I can also make here substitution for L into L plus 1, which is 2 A by B minus ml square. That is one way to look at it. So I will have here, this can be rewritten as minus this, here I can write it as 6 A by B. So this is, here you can see L into L plus 1, this term I can write it as 2 A by B minus ml square. So 2 A by B minus ml square. So I will have, I will write here ml square, and so this will give me ml square, and I will have ml square times, this will give me, on solving we can actually write this term as 8 ml square, and then that would imply that, look at this, this is 0 and I have, if A by B is 1, then only this is possible, right. So I have made the substitution from this equation. So 2 A by B I have here minus plus ml, okay. So I had minus A by B ml square is equal to ml square, which means A by B is 1. So when A by B is 1, here this is 2 minus 4 minus 6, that is minus 4. So I will have, let me, and we have used L into L plus 1 as 6, correct. Now substituting this, I obtain ml square is 4, which is nothing but ml is plus minus 2. So you have got the value of ml A by B and L into L plus 1, okay. So this is one set of possible solution. You can have more solution, one more solution I have actually, you can work out and find out. So for this set of solution, one can obtain the value of capital phi as, solution of phi as phi e raised to plus minus 2I phi. When you find out the normalization factor, you obtain, this is nothing but 1 upon square root of 2 pi e raised to plus minus 2I phi. So this is the solution. Let me write here as 1 upon square root of 2 pi e raised to plus minus 2I phi. And similarly, you can obtain the solution for theta. This is capital theta has the solution of the form minus A sin square theta, okay. Let me box it. So this A, or I can call it as A prime, is when you find the normalization, you obtain this, Okay. So, one set of solution for the ratio A by B is 1, ml is plus minus 2 and L into L plus 1 is 6. You can infer the value of L, correct. L is 2. So, with this we discuss this possible case. Now, let us go to the next exercise. Next exercise is you have to find out some relations of polyspin matrices. So, poly matrices, as you have already seen, that they follow certain relations. Okay. So, you know this sigma x, sigma y and sigma z are polyspin matrices, and you know the properties of polyspin matrices. So, if I write sigma I, sigma j, this is nothing but 2I sigma k. These relations we all know, and even these polyspin matrices, these operators you can write in terms of SI also, okay, that you all know. So, using these properties, and you know that these properties can be used to calculate the problems given to you 2A, 2B and 2C. So, these exercises you can try out yourself, it is just 1 or 2 step problem. And for the first one, if there is a sigma A, sigma dot A, you know we can write it as, and sigma dot B. So, you can expand it in terms of sigma x A x plus sigma y A y plus sigma z A z, and the product, and you will get a dot scalar product as well as the vector product. So, you can just obtain this by making some substitution, that those exercises are for you to practice. So, problem 2 A, B, C and problem 3, these are all practice problems. So, please try problems 2 and 3, okay, A, B, C as practice. Okay. If there is any difficulty, we can always have a discussion. And the third problem is what will be the nature of operator Lz minus H cross into Lz plus H cross. So, you have to assume the eigenstate of Lz as plus and minus state. You know, you can write understand now that how to write it in terms of plus, minus and 0 state. We discussed in the last tutorial. So, using this information you have to find out the nature of this operator, which is again a few step, 1 or 2 step problem. It does not take much effort. So, these exercises will give you a way to look on these polyspin matrices, and the operator notation you are now very much comfortable, I hope, and are familiar with. So, this is the part of tutorial which I wanted to discuss today, and I hope that you all are practicing these problems on your own, because these tutorials will be very beneficial for you all in solving the assignments, weekly assignments. So, hope you are getting enough time and you are solving these exercises.